Amazon ECS is highly scalable Docker orchestration service. ECS provides cluster of EC2 instances where we can go and run our Docker applications. We usually see two flavors. One is just AWS ECS. In this, we get EC2 instances exposed where our Docker containers are deployed. In this case, we need to maintain EC2 instances by doing all patching and update works. And the other flavor is ECS Fargate. When it comes to Fargate, Amazon will not expose underlying EC2 instances, so that way we will not have to maintain the underlying instances, all that stuff. As part of this demo, I'm going to show you how to deploy multi-container applications into a Fargate cluster. We're going to have Redis as a backend and Python as a frontend. Python application talks to Redis. So Python talks to Redis with help of service discovery in ECS Fargate. We'll be seeing all of that as part of this demo. Before we get started with demo, let's have little idea about the components of Fargate. In order to deploy any container into Fargate cluster, we need to first define a task definition. As part of task definition, we will describe few details about memory, CPU, the containers we want to spin up, environment variables, commands, volumes, and so on. And clients can talk to this task using its IP address and port number. In case any task in the cluster crashes, ECS will automatically spin up a new one, maybe in same node or different node, and IP address is going to change in such cases. If IP address changes for new task, the client will have trouble connecting to that specific task because IP got changed. So this is a biggest problem if clients directly talk to tasks, and to solve these problems, Amazon ECS has a concept of service. Service will never go off and they will never change. The service in the background is connected to tasks. If any task crashes in the cluster, ECS will spin up a new task which comes with a new IP, and that new task automatically joins this service. So that way client will not have any problems when a old task is crashed and new task comes up into the picture. Let's head over to AWS Management Console and let's go and implement the diagram I have shown. Alright, so select clusters, create cluster. I want to use AWS Fargate. Go to next. Let's name this Java Home. I don't want to do any networking selections, just hit create. So view cluster. The next step is to create a task definition for Redis. Create new task definition. A launch type is Fargate. So task definition name, I'm calling it Redis. Task role for this example, I don't want it. Network mode, for Fargate, network mode is always AWS VPC. We do need a task execution role, so I have a default role created. If you don't have this, just click create new role. It automatically creates an appropriate role for you. And the task size, we need to specify task level memory, task level CPU. Let's have 1 GB memory and half CPU. To this task I want to add containers. I want to have only one container here. So Redis image. So this image comes from Docker Hub. which is in internet. You can set soft limits like what's a minimum amount of memory that needs to be reserved for this container. Port mappings, I do not need port mapping for this specific task, for this specific container. CPU, let me say 512. Okay, I don't have anything else to provide. Let's go and add this container. Likewise, you have options to add multiple containers. So if you see this bar, a CPU is fully utilized by this container, but we did task level CPU allocation 124 MB, and for container we allocated only 128 as a soft limit. But it doesn't mean the rest of the memory cannot be utilized. I mean, on demand, your container, Redis container, can go and utilize maximum 124 MB. So this is my task definition. So usually task definition deals with what's the image, what is the CPU, memory, commands, environment variables, volumes, and so on. Let's create it. Let's view this task definition now. Okay, so we have a task definition created. The next step is to have a service in front of Redis. As we discussed, uh, connecting directly to a task is not a good practice. We'll have a lot of problems. So go to cluster, open this, under services, create a service. Launch type is Fargate. So task definition is Redis. It seems I previously configured one more revision, but fine. So that specific task definition version, platform, I'm leaving it default cluster. I want that to be in Java home cluster. Service name, I'm using Redis. Number of tasks, I want only one. I'm not running Redis in a cluster mode like where we have master and workers, so I'm choosing one. Coming to deployments, leave it as default, which is rolling update. Go to next, and don't forget to choose the VPC where you want to set up all your cluster and tasks. I'm choosing default VPC and select multiple subnets for high availability. It's by default creating a security group. Let's edit and make sure we have right ports open. For keeping it simple, I'm saying all traffic, but real time, make sure you open only a port that needs to be opened. So this security group is used for anybody to connect to Redis. If Redis is running on ABC port, make sure you have opened ABC port here. So auto assign public IP, I want this to be enabled. Generally Redis is backend. We should not expose it to internet, but still why I'm enabling it, it has to connect to internet to pull my Redis image from Docker Hub. So in real life scenarios, your image might sit in private registries within intranet or your own Docker ECR. In such cases, you don't have to expose your services to internet. So load balancing, I do not want now. A namespace, I want to create a namespace for service discovery. So this service discovery is important for my Python application to connect to Redis. So you can give any namespace. I'm giving javahome.in as a namespace, and service discovery name is Redis. So it overall becomes redis.javahome.com. If my Python application wants to talk to Redis, it should point to redis.javahome.com. Say next. I don't want auto scaling. Create the service. Alright, the service created successfully. Let's view. Go to cluster, open that, see the service with name Reddish is created. It is using Reddish task definition to create Reddish container. So go to tasks. See, it is spinning up one Reddish task because in service level I said number of tasks 1, so it's spinning up 1. If I say number of tasks 10, it's going to spin up 10. And at the same time, if any of that desired capacity is not meeting, if our desired capacity, nothing but number of tasks is 1, and we don't have that one task in the cluster, service takes care of recreating that task for you. And the task is in running state. So we have the backend service ready. We need to go and set up the front-end service which connects to Reddish, and let's see by accessing that application from browser. If you see this diagram, before I go and set up my Python service, I need a load balancer ready. So I want to integrate my application load balancer with my Python service, where I want to have more than one tasks. If I have 3-4 tasks, I want all those tasks to be load balanced using application load balancer. The next step is go and set up ALB. Go to EC2. For ALB we need target groups. Create a target group. So I want to create target group for my Python. So target type is IP. ECS, when we integrate this with ECS, it adds the task IP addresses to this. A protocol is HTTP. Port number I need to check. My Python application is configured to run on 5000. I want to use 5000. So VPC, obviously it has to be default. So everywhere you select VPC, make sure you're selecting same VPC. So health checks, I'm fine with HTTP and path / advanced health check settings. I'm fine with these details also. Let me bring down this to 2 and create it. So the target group is successfully created. Let's go to load balancers, create load balancer. It is application load balancer. Okay, I'm calling it as Java Home ALB. I want that to be internet facing, and I want that to listen on 80. Availability zones VPCs, I said we all running in default VPC, so make sure you're selecting same. So security groups, it is security settings. So I do not have any SSL certificate. This is blank. So coming to security groups, I opened 80. If you open 80, that should be good enough, but I'm selecting a security group which has all ports open. So target group, existing target group, Python. So all this is defaults. Next, register targets. I don't have any targets here to register directly. When I integrate this ALB with my ECS cluster, it automatically takes care of adding targets to this. So review, create. Yeah. So we have ALB ready. The next, go to ECS cluster. Create task definition for Python. Create new task definition. Launch type is Fargate. So Python default role, memory, CPU, add containers, image. So I have image, my own image, which is pushed into my Docker Hub account. So it is a public image. You can try same for your demos too. So soft limit, I'm configuring some default values there. So port mapping, if we have ALB configured, this you can leave as 0, which is taken care automatically by the cluster. So health checks, I don't have anything to do. CPU, let me put 256 or 512 units. Okay, and environment variables are important because to my Python app I need to pass environment variable, which is Redis host. So Python application expects this environment variable, and I need to put redis.javahome.com. If you guys remember, while configuring service discovery for Redis, I gave service name as Redis and javahome.com as my DNS record. So this information is passed to your Python container. Python uses this information and connects to Redis. All fine. So add, something is wrong. Okay, let me choose 5000, which is my container specific port. So add and create. Yeah, so we have couple of task definitions, one for Redis, one for Python, and we have only one service which is created for my Redis. I need to go and create one more service for my Python task definition. So create Fargate, it is for my Python, true. Revision, whatever is latest there. Cluster name, service, I want to have service name as Python. Number of tasks, you can put 2, 3, whatever number of tasks you want. If you put 3, service will go and create 3 different tasks which contains 3 different containers for load balancing and scaling, all that stuff. So deployments, I'm going with rolling update. Next, I need to select my VPC. So we need to consistently select same VPCs throughout all the places we did a selection of VPC. Security group, let's add, change all traffic anywhere. So yeah, this is required, public IP is required because we are exposing it to internet. So coming to load balancing, I want a load balancer to be configured. Application load balancer name, it auto selected, and even this, it comes up automatically. We created a task definition, we created a target group with Python. So say add to load balancer. So coming to listener port, we already have 80 port configured in ALB. I'm selecting that. So target group name Python, meaning, so any request coming to ALB on 80, that must be forwarded to a target group Python. To this Python target group, ECS will add all your 3 tasks we are defining as part of this. So service discovery, if we have some other service which talks to Python, then configuring this is important. But in our demo, we don't have any service which talks to Python, but still I'm going with existing namespace, and my service discovery name is Python. Even if you say none for this one, that is still fine. Next step, I don't want auto scaling. Next step, create service. So it quickly created service. Go to clusters. We have two services. Go there. Python is one, Redis is one more. Desired tasks for Python, it is 3, and Redis it is 1. Go to tasks. Yeah, see that. So Redis is already running. We have 3 new tasks coming up for Python. If all goes well and good, our application should be up and running. Let's wait for a while now. One has become running. Yeah, all is running now. Let's go to EC2 dashboard and see what's happening in ALB there. Target groups. Let me check first target groups, which is only one Python. Targets, see this one. So 3 tasks automatically registered to this ALB. Go to load balancer, pick up your DNS name and hit that, of course. So we successfully deployed multi-container application. 1 second, this number of hits, right, this is coming from Redis. If I go and stop Redis service, it will throw exception saying could not connect to Redis. So we successfully deployed multi-container application with service discovery. Before closing this session, I want to show you how to release next version into the cluster. So imagine we have a new release for my Python application. What we need to do is we need to go and create a new revision. So create new revision. Of course, task definition name is Python. In the container image, I will make it 2. So I want to deploy the next version of my Python. So update it, create it. So go to task definitions, go to Python. See, we have 2 revisions there. The new revision is created. The next step is update the service to point to this new revision. So clusters, Java home, Python, it is pointing to Python 4. Let me say update, I will point it to 5. Next step, next step, next step, and update the service. So I have created a new revision which points to the latest image we have, and I went to services. I updated my service to point to that new task definition revision. Go to clusters, go to tasks, right? See that. So new tasks are coming up with a new revision, and eventually old tasks with old revisions will go off. So if you keep hitting this application, So eventually we need to find the latest version which is deployed. Still I don't see. So what I did in new version, I changed the color. If color changes here, then our new version is up and running. So let's also have a look in, yeah, see that one. So old ones are draining out and new ones are coming up. So our new version is successfully deployed without any downtime. So thanks for watching. Thank you.